draw a couple functions, common functions. Let's look at their graphs. And let's look at how those graphs can help us solve equations. So we'll focus on specific functions. So we have linear functions, we have quadratic functions. These are all words that you should have heard before and are familiar with, but if not, then it's okay. We'll see what they look like here. Then we have cubic. Then we have an interesting one. We have exponential. I'll write that here. Exponential. And then, yeah, let's just keep it at those four for now. So linear. What does linear look like? So linear curves are of the form, or these are actually lines. So these are of the form y is equal to mx plus c. So for each given value of x, you'll find the value for y, because you'll be given m and you'll be given c. So m is the gradient, c is the y-intercept, and it's just a constant, and x is like the x coordinate. So this is a rough sketch. I'm gonna do rough sketches here, and then soon we'll go to graphing paper and look at proper sketches. So y is equal to mx plus c is gonna look either something like this. This is if m is positive, and if m is negative, then it's gonna look something like this. As in, the line is gonna be sloping downwards. That's y is equal to mx plus c. That's pretty simple. We've seen this before. There's a video on lines that explains this. Quadratic. These are very common as well. So usually they're in the form y is equal to ax squared plus bx plus c. And if ax squared, if this term right here is positive, so if a is positive, then our curve will look something like a U shape. These are called parabolas. So you can write that down if you want. These are called parabolas. And if a is negative, then it looks something like this. So I'll do it right here. So this is y is equal to negative ax squared plus bx plus c. And it's gonna look like an upside down U. So these are also called parabolas. It's an upside down U. Well, with a being positive is a positive. It's like a regular U. Cubic looks something like this. So these are equations of the form. You probably guessed this by now. So y is equal to ax cubed. By the way, a, m, c, b, all of these are just constants, just random numbers. So ax cubed plus bx squared plus cx plus d. And these look something like this. So it goes up, goes to a maximum point, comes down, goes to a minimum point, and then goes back up. So that's a cubic. And what if a is negative? Well, then if a becomes negative, then it comes from the left side. So it comes down, goes to a minimum first, comes up, goes to a maximum, and then goes back down again. And of course, changing b, changing c will make a difference. Changing d is always just going to change the y-intercept. So the constant always for any curve whatsoever you can think of will always just be changing where it intersects. So that means this right here is the point D. This right here is the point, well, the constant in this case is just c, so that's c. This right here is the point C. This right here is the point C. This right here is also the point C if for the y is equal to negative mx plus c. So c is always just a constant, or d in this case, and it's just the y-intercept of the curve. B and c are like more difficult to explain. They like stretch the curve or shrink it a little bit. Like they do many different things. So you can like experiment with, you should go to GeoGebra. I'll write this down here. So this website called GeoGebra, and you can play around with some of the curves there, and it's very interesting to see what they do. Exponentials look like this. So they're of the form y is equal to a to the power x, where a is just any number. And if a is greater than 0, then they look something like this. That's y is equal to a to the power x. I will only deal with the positive a part for now, but you can make it negative a to the power x, you can make it a to the power negative x, you can make it negative a to the power negative x. It just gets complicated, but I think a to the power x is pretty simple for now. So let's do some actual curves. So let's say we had y is equal to x plus 3. What would that look like? Well, let's say that's 3 right there. So that's our y-intercept right there, 3. And for each y, so let's say x is equal to 1, y is equal to 4. So x is equal to 1, y is equal to 4. X is equal to 2, y is equal to 5. X is equal to -1, y is equal to +2. So that's right there. X is equal to -3, y is equal to 0. Let's say we have that right there. Because -3 plus 3 is 0 and all that. And then you can just connect this line, of course. And of course it's a straight line because it's a linear curve because m doesn't change. So it looks like that. Let's say you had y is equal to x squared plus 3x plus 2. What does that look like? Well, I guess I'll be a little bit precise. So let's say it crosses there and then crosses there and then goes back up. So that's the point 2 right there. I know it's not exactly 2 because that's 1, but we can make, it's just a rough sketch, it's not exact. And that's going to be -1 and that's going to be -2. If you don't understand why it's -2 and -1, you should be able to see it from this curve, but if you haven't, then you should go watch the video on quadratic equations because that explains where it crosses the x-axis. Because where it crosses the x-axis is when y is equal to 0. So that's what a quadratic looks like. Alright, so let's talk about a cubic curve. So let's say we had y is equal to, let's say x cubed plus 2x squared plus 5x plus 1. Well, we know 1 is the y-intercept, so that's going to be somewhere here. And then it's a regular cubic, so let's say it comes up, is going down, reaches its minimum somewhere here, and then goes back up. These are not very exact, but pretty rough estimate, and I think it's a good estimate. And now let's say we had exponential. Let's say we had y is equal to 3 to the power x. Well, when x is 0, y is equal to 3 to the power 0, which is 1. So that's there. When x is equal to 1, y is equal to 3, so let's say that's over there. X is equal to 2, y is equal to 9. That's already up here somewhere. It's not exact, but it's up there. And then when x is equal to -1, y is equal to 3 to the power -1, which is 1 over 3, so that's somewhere here. And I'll tell you, as x gets more negative, you approach 0. So this is called, so I'm going to draw a dotted line right here, a dashed line. And this is called an asymptote. An asymptote is like what a curve approaches but never really touches, and in this case that's just the line y is equal to 0. Don't worry about it too much. All you need to know is that this exponential looks something like this. So it's almost at 0 and then suddenly it shouldn't be going down there. It should be like almost straight. In fact, it should always be going up, but we can't really tell the difference because it can't be that precise. And then suddenly it just goes up and keeps on going up and up and up very fast. So that's what an exponential curve looks like. Now, how would you solve equations? So let's say you had y is equal to 2 to the power x, and you had y is equal to x squared plus 4x plus 3. Let's say you had two curves, right? So let's say 2 to the power x looks something like this. Say something like that, and then goes up. That's y is equal to 2 to the power x. And then you had y is equal to x squared plus 4x plus 3. Let's say that looks something like this. Let's say that's y is equal to x squared plus 4x plus 3. Something like that. Well, how would you find the solutions to this? Let me draw that better. Let's draw it like this. How would you find the solutions to these equations? So what value of x would satisfy both the values of y? And if you remember, these are actually simultaneous equations. And what you would do then is you would read off the value right here, and you read off the value right here, where they both intersect. So that's x1, and that's x2. And then from here you can read off the value of y by drawing a straight line, and that would be y2. Then from here, I know it looks like it's on the exact same, but it's not the exact same line, it's different. And that would be y1 right there. It would be a little bit above y2. So x1, y1 is actually a solution to the simultaneous equations of these two. And then x2, y2 is also another solution for the simultaneous equation if you had these two, if you had both of these curves. So yeah, it's a very quick video on like what most of these curves look like. The important thing is that a line is just straight, m is the same. Quadratic looks something like a U. A cubic has like a maximum point and then a minimum point, and an exponential looks something like this. It never goes to the negative side, so like this side never approaches that, never comes to that side. It's always above 0. And solving two equations is just simultaneous equations. And instead of, you can't solve this equation with the tools you have right now, so you just draw the two curves and you can find out where they intersect and you can solve from there. So yeah, it's a quick video on plotting some common functions, and yeah, I hope you enjoyed the video. If you did, please like, share, subscribe, and comment, and let me know what else you want to see.